welcome to episode 270 of our SAP on Azure video podcast. Today is December 2nd, and together with Goran, we are here to talk about anything related to SAP and Microsoft. Hello, everyone. So in recent episodes, we talked about securing your SAP systems using Entra ID, implementing MFA, or using Sentinel to detect attacks. But what about the foundation, the Azure Network? So today, I'm really glad to have Evren and Saleem with us to take a closer look at Azure's central point of connectivity and advanced threat mitigations. Evren, Saleem, welcome to our show. Before we dive into the topic, let's start with a quick introduction. I mean, Evren, you have been here so many times already. I guess everyone knows you anyways, but maybe just to kick it off, what is your role? What do you do at Microsoft?
Sure. Hi, everyone. My name is Evren Buyruk. I think this is my 7th time on this podcast that Holger and Goran have been hosting. So I'm with Microsoft. I'm with Microsoft International Customer Success Unit, and I focus on networking and security and everything around like best practices implementation for customers. And I specifically am assigned to one of our Microsoft S500 customers, and I have been their go-to person for networking and security. And then my main area is working with product groups and product group members like Saleem, my colleague here. So what we're doing here on this YouTube channel that has been hosted by Holger and Goran is to introduce Microsoft core technologies to make this cloud implementations safe, quick, and actually just expandable. So it is the reason why I'm here. And again, Holger, thank you so much for hosting me.
Thank you so much for joining us. Saleem, over to you.
Yeah, absolutely. So my name is Bseeu. I'm currently a senior product manager in CXE, which is Customer Experience Engineering team. And I'm specifically in Azure Network Security team, which means that I work a lot with Azure Firewall, Web Application Firewall, and also Azure DDoS protection. And yeah, I'm very glad to be here. So thank you.
Great. So let's kick it off. I mean, I think I have the two best experts to talk about this here. So let's introduce the topic.
Let's do that. Let me actually just start with presenting my screen, and then we just go from there. So let me know if you can see my screen.
Yeah, it's coming up. It's loading.
It is coming up.
There we are. Yes.
All right. So the topic is, as you can see on the slide, is the Azure Central Point of Connectivity and Advanced Threat Mitigation. So we're going to be actually diving deep into the topic, and the message that we're trying to actually just give to our audience today is how easy it is actually to secure the SAP workloads or even any application that runs on Azure. And then the core technologies that we actually just provide is really just stacked on like the central point of connectivity to Azure, and then how the connectivity is actually just been designed and implemented. So there's some terminologies and there's some topics which have been very confusing for customers that go to our websites or even our competition websites to understand common terminologies and common technologies about what these are, like the Azure region location and express route location. So most of the time what we hear from the customers, what is the difference between these two? So basically, before we actually just go into all the solution components to secure the SAP workloads on Microsoft Azure, this terminology is important. So basically, at a high level, but for people to really understand, without spending a lot of mental energy about these things, Azure regions are global data centers where Microsoft Compute, Microsoft Networking, and Microsoft Storage resources are located. Basically, the resource location is determining which Azure data center, or we have the concept and we have the construct of availability zones. And then this is really just big indicators for the resource which is created in Azure. Basically, it is the Azure regions. Again, these are just the global data centers where compute, networking, and storage resources are located. So what about the express route location? And then I'm also going to be talking about what is express route and what exactly express route can do or is doing for customers or enterprise grade or medium sized customers, what it can do for them. So express route location first is the co-location facilities where Microsoft Enterprise Edge, and our audience might see it like the abbreviation, which is MSEE. It is actually Microsoft Enterprise Edge. So express route locations are the entry point to Microsoft's network, and these are globally distributed, providing our customers the privilege or the opportunity to connect to Microsoft's network all around the world. Basically, these are the locations, and then these locations are where ExpressRoute partners that Microsoft has been working with and ExpressRoute direct customers, they issue these cross connections to Microsoft network, and it is how they actually just get connected to. So in general, what ExpressRoute location and is about is that I will say that it does not necessarily need to match the Azure region. So it can be anywhere. So like if a customer is on East US 2, for example, or they would like to move to East US 2, so it can actually just be anywhere. So it does not necessarily have to match the Azure region. For example, that a customer can create an express route circuit with the resource location, as I mentioned it in East US 2, and then in the Seattle peering location. So basically East US 2, and then the peering location is in Seattle, which is just going to be all the way across. Basically, express route location is not the same as a region. So when you are considering it, you're selecting express route location nearest to your customers, like on-premises, co-location, or DC location. So this is really just bringing the Azure, cloud closest to you. So basically, from the best practices for the proximity, you just need to just work with your express route partners to identify which location is going to be the best for you to actually just configure and set up your express route enterprise edge, express route connection, and how you actually just deal with the pipes and then the implementation through the express route, Microsoft Express Route partners. So after this, explaining about the differences, I would like to just talk about the express route, what exactly it is. Basically, it is one of the most important part of the networking and security for SAP or non-SAP on Azure. This is a dedicated outside the internet connectivity to Azure data centers. Again, outside the internet connectivity. So when the client or a customer goes and just deploys this express route circuit, they are going to have two type of peering, which I am also going to talk about the peering, what exactly it is. So two type of peering, which is to access the public facing workloads. And then the other one is the private peering, which is to access the virtual networks, VNets, or the shared services for the virtual networks. So, and all the other components which are not public facing, or they're not, burdened for the public access, are actually just on the other route. So express route circuit is a private connectivity to Azure data centers. So basically, these circuits, the express route circuits, are allowing our customers to, connect to Azure, and then they can actually just get, up to 2 times the bandwidth limit for no additional cost for them. Basically, when the customer needs that little just buffer on that connectivity bandwidth, basically they get this burst, and then there's no cost for the customers. So what happens is, when I talked about two peering locations, and then one of them is the private, to other one is to the public, I would like to talk about the circuit, and then what exactly it is within that two virtual passes connecting to the Microsoft Edge. So express route has one circuit, is always going to have one circuit. So if a customer needs to have an HA, our partners can enable two express route circuits, such as, I will say, ECUS, ECUS2. So there's a confusion. Hey, I'm going to get my express route circuit, and then Microsoft is giving me HA, or I can actually sign up to an SLA, which is just going to factor in the HA in the solution. The answer is no. Customer, when they deploy, they're going to have one circuit. They're going to call their express route partner, and then express route partner is going to go ahead and bury another express route circuit. So then this can be in East-West, or it can be in East-West2. Basically, in the region, customer can have two circuits. So the reason why this is important is it is going to give this customers the circuit level resiliency in case one express route circuit is impacted or broken. So this is very important, and I really would like the audience to really listen to this. When a customer, if you're a customer listening to us right now, you need to design your HA solution by just simply calling your express route circuit partner. They are going to be working with you on the HA. But for you to actually just enable express route circuit, you just need to go ahead and just do Azure portal. You can actually just deploy it from there. But you have to have your preparation all completed. You have to have your circuit setup completed. Then you go to Azure portal, and then you actually just go ahead and just like deploy. So clients can also leverage this connection weight to prefer one circuit to another. Like I mentioned, if you go ahead and just do two circuits, so this is going to be for your HA purposes, you client can go ahead and just use the connection weight to offset your connectivity. One circuit over another one is all up to you. So by default, the traffic leaving the VNet is going to be routed based on this equal cost multi-path routing. But the connection weight can do the routing based on the preferred circuit. Who knows that preferred circuit? Myself, I don't know that. Saleem is not going to know that. It is you, customer, who's going to know where to actually just weigh. Basically, you're gonna design your solution, and then you're going to know, your network admin is going to know where to actually just do this balancing to what circuit. So most of the clients, they usually just like, leverage this connection weight to prefer one circuit to another. But by default, again, leaving this, VNet is always just going to be routed based on that, like, equal cost multi-path routing for the traffic leaving. But again, it's all up to the customers to leverage the additional circuit. So most of the time, so this is where is actually, rubber meets the road. Express route is important is because it is providing media access control security and IPsec for encryption. So what it does, MACsec is providing this layer 2, and IPsec is providing the layer 3 security. So basically, MACsec is the IEE standard, and IPsec is IETF. From the compliance perspective, by leveraging express route and express route over the IPsec, you're actually just leveraging two strong encryption, which have been actually just certified. IEE, the other one is IETF. Basically, it is how we are getting our customers started with this. So then, of course, that we have the express route with Microsoft peering. This is to allow accessing Microsoft and Azure services over a dedicated connection. So this is including like, like other things like Office 365, Dynamic 365, and various Azure, services, such as the virtual machines and the storages and, so on. Basically, this is how we actually just get our customers started with express route circuit. Then the question that is coming, so these slides that have been actually just put together just to address the common confusion, just to address the common, ambiguity in the market about the options, like connectivity model overview is actually just going to give the options for the connectivity models. So basically, the services provider model that you see on the screen is actually what happens is that the one that is actually just highlighted in the big underlining, line. What exactly it does, it is involving using a third-party service provider to facilitate the connection between customer on-premises infrastructure and Microsoft Azure. So then the cloud exchange location that is actually just underneath the services provider model, what you do is that you're placing your infrastructure in a co-location facility that is connected to a cloud exchange.
Mm-hmm.
Basically, the cloud exchange is then going to connect to Azure via the express route. So this is important, and of course, the people can pause and just listen again. So, and then what is that ideal for, right? The question is, it's ideal for companies or businesses already using co-location service. It is your best option. If you're using co-location service, go with the cloud exchange co-location. So the second one, the point-to-point Ethernet connection, which is actually, still dedicated Ethernet link between the customer's data center on Azure, and it is really offering this high performance and low latency. So it is the ideal use case for it is just like for organizations needing direct private connectivity. So any to any, which is something which is provided, is actually leveraged by many customers. So basically, it is using a provider's IP VPN, which is also called MPLS network, to connect multiple sites to Azure. So what it does for multiple sided companies, it is really simplifying the connectivity for distributed enterprises. And then it is really just like enabling the centralized management and routing for them. So that is something that they prefer. So direct model is the model which is allowing large enterprises to connect directly to Microsoft Azure without going through a services provider. So basically, with ExpressRoute Direct, you actually just have, as it says, the direct model that you're not using a service provider, and then you go. So the ExpressRoute site that we actually just need to just mention, this is the direct connection from site to Azure. Basically, it is offering the full control and potentially lower latency. It is again best for organizations with advanced networking and then advanced capabilities and compliance needs that we just go with that option. So the ExpressRoute peering types. So like I mentioned, this is actually the highlight or expansion of the first slide on the ExpressRoute, the primary connection and secondary connection. Then this is again not AHA. Basically, this is one circuit representation of two paths. One of them is the primary, the secondary. These are virtual connections. Basically, this does not include the second dedicated circuit. So I'm gonna explain this. This is gonna be a little bit more, comprehensible. Basically, the private peering that we are actually just talking about is really just enabling this private and dedicated connection between the left side on customer premises network and Azure Virtual Networks. So the use case for this is, I always just say that I want to give the use cases. Okay, I'm explaining, well, what is the use case for this, right? It is to access to Azure infrastructure as a service or platform as a service services deployed within virtual networks, let's say VMs, premium disk version 1, storage accounts, like the storages. And then from the security point of view, the traffic is not traversing the public internet.
Yeah.
Basically, it is the primary private connection. It is ensuring isolation and confidentiality. Now the question from the network and routing people, is this supporting any RFC protocols? It is supporting RFC 1918, address space. Of course it does. So it is also doing the custom policies. Now the question, performance. What is it? Offering low latency is number one, minimum throughput connectivity. Minimum effort on establishing connectivity to achieve very high throughput connectivity, which is ideal for mission critical workloads. What is the mission critical workloads? SAP is one of them. Yeah, that is the reason why we're talking about how important it is. Microsoft peering, what exactly it is, right? Like, it's an exam question. Most of the time, people when taking exams, what is it? What is Microsoft peering? This peering type provides access to Microsoft public services. Like I mentioned this, such as like Office 365 and Dynamics 365 and Azure PaaS services. Why do you need to have the Microsoft peering? Because you're going to need to have a connectivity to Microsoft public endpoints using public IP addresses. Otherwise, you won't be able to use Dynamics 365. You won't be able to get any of those PaaS or IaaS services. So you have to have it. From the routing perspective, it is going to require route filters that you can actually just establish to define which prefixes are going to be advertised. This is important. And then it comes to security, like what exactly it is. What is it using? It is using NAT firewalls at the Microsoft Edge level, which I mentioned in the first slide, and you guys can also see this. This is the partner Edge. It is using the NAT firewalls at the Microsoft Edge to enforce stateful traffic inspection. This is important. So these are all the areas which we can actually double click on more dedicated sessions, but this is a walk through to our advanced threat protection. What did we achieve so far? We actually established dedicated private connectivity and then other options to Azure. So it is our now getting to the hub. And then we are just going to be actually just talking more into what exactly it is. So then resiliency topics. So like I mentioned, standard resiliency in ExpressRoute is, again, single circuit with 2 connections which are configured at a single site. So this is the built-in redundancy, which is always just active-active, is configured to facilitate failover across 2 connections of the circuit. So what we are doing today with Azure from the ExpressRoute offering perspective, we're offering, again, these 2 connections at a single peering location. So if a failure happens, what happens is that, like they say, that there's a failure at the site, users might experience loss of connectivity to their Azure workloads. So this configuration is also known as like single homed, as it represents like users with an ExpressRoute circuit configured with only 1 peering location. So basically, this configuration that I'm mentioning is considered the least resilient and not recommended for business or mission critical workloads. So basically, if you are a SAP on Azure, or if you're a customer on premises today, and then you would like to actually have a redundant central point of connectivity to Azure, you are not going to look at the single homed, because this is not going to be for you. High resiliency, also referred to ExpressRoute Metro, is another one. This is enabling the use of multiple sites within the same metropolitan or metro. And then this is the metro area. So we are actually just using it to connect your on-premises network through ExpressRoute to Azure. So, and then the high resiliency, this is the second one that I'm talking about on the chart. It is offering the site diversity by splitting a single circuit across 2 sites. Again, single, and then again, single circuit. So that's why it is not necessarily just going to be an ideal. The first connection is going to be established at one side and the second connection at a different side. This is so important. This needs to be immediately just like, noted. Again, 1 circuit split into 2. Is that an HA solution? You just decide. So the objective of ExpressRoute Metro is to mitigate the effect of edge site location and failures by introducing capabilities to enable like site diversity. So what is site diversity? It is really just like, how is it achieved? It is achieved by using a single circuit across paired sites within a metropolitan city. So this is just going to be offering this resilience to failures between edge and region. Basically, when a customer gets the metro, it is going to providing them a higher level of site resiliency than the standard resiliency, but not as much as the maximum resiliency, which is the one on the very right side. because this is going to be used for businesses, enterprise-grade customers, or customers who are leveraging SAP. This is the mission-critical workloads set up within a region. Basically, it is going to be actually just like, structured to eliminate, or it has actually just been structured to eliminate any kind of single point of failure within the Microsoft network path. So this is the setup, which is achieved by, configuring a pair of circuits, plural, across two distinct locations for site diversity with ExpressRoute. This is how you're achieving your HA. So basically, the initial slice that I mentioned about single circuit, then one circuit split into two, which is the high resiliency metro, and then the maximum resiliency, two dedicated circuits. This is the HA solution for the ExpressRoute circuit.
Yeah.
And now, before I actually just turn the presentation over to my colleague, Saleem, everything that we talked about so far is to make sure that you're connected to Azure with dedicated circuit, and you enable the secondary one on a different site that you achieved your self HA, right? This is important. So now you're making all that investment. Basically, you're bringing all your resources to Azure Hub, which is your central point of connectivity, which is the guy that is actually right here on this shape, on this square. And then on this like rectangular, I don't even know, is it a rectangular or whatever it is. So, and then the spokes, right? And then I talked about the VNet peering. I talked about the ExpressRoute connectivity, and then ExpressRoute Edge, the Hub VNet, which is the central point of connectivity, is actually the central point of connectivity to your on-premises network, and is a place to host shared services that can be consumed by the different workloads, hosted in the spoke VNets. The Hub VNet is typically mapped directly to an IT subscription, which is to provide network, transit. Like all the ExpressRoute gateways, VPN gateways, MVAs are just going to be located in this network. So any virtual machine or like the workloads deployed in the Hub VNet will be invisible to tenant subscriptions that are mapped to spoke VNets. This is actually maybe a good answer for subscription level multi-segmentation. Maybe somebody can actually just take a note. So basically, give your IT the rights and permissions for the hub, and then all the other spoke VNet subscriptions, they're not going to be able to actually just see or monitor or control what is going on the Hub VNet. This is your central point of connectivity, and then make sure that right people are assigned to have read and write access to the hub connectivity. The spoke VNets, these are the ones, one or more Azure VNets that are used as spokes in the hub and spoke topology to actually just communicate with the Hub VNet. Basically, the spoke VNets are focused on this tenant workloads, and these are really just could be a representation of different application states. It can be like the application, or the departments, I will say, that, or lines of businesses, it might be. So it is coming for IT and security professionals to be granted role-based access RBAC to these spokes to maintain infrastructure components such as VNets, or who's spending a lot of money, who's not, or something like that. But this is how you're achieving your multi-segmentation on subscription level. So now we're talking about the technologies like the Azure Firewall, and then we talked about VNet peering. We talked about some of the other components that we didn't necessarily go deeper into, App Gateway, for example. So when you have App Gateway, you're achieving yourself layer 7. You have the mutual TLS option. You have private IP only option, or you are having a public IP address assigned to your App Gateway, and then you have your Azure Firewall side by side. You're using UDRs in between. You're actually just doing the next hops configurations and GLR gateway last resort configurations. But who's going to protect these guys in the Hub VNet or the spoke VNet? So now the question is that, okay, tell me a solution which is going to secure my Azure Firewall Azure Firewall is going to inspect my monitoring for layer 3, 4, sometimes layer 7. Application Gateway is going to be doing my layer 7. And then what is the technology that is going to protect my assets on Azure on the hub and spoke topology? Now I'm going to turn it over to my colleague Saleem. He's now going to talk about what is going to be protecting these assets in the hub and spoke minutes. Saleem, is all yours. I'm going to stop sharing my screen.
Awesome. Thanks a lot, Evren. All right, so let me start sharing my screen here. And taking over from Evren. So as Evren mentioned, he talked about the central connectivity, about the resiliency. I'm going to go a bit deeper about Azure DDoS protection. So Azure DDoS protection is a native Azure native cloud solution. It's for providing protection against layer 3 and layer 4 type of DDoS attacks. And you can see here, these are some of the features. It's global network, has adaptive tuning, attack analytics, integrations, and other features that I will go into more details. Here on the right, you can see how you can protect all the resources where you have the public IP addresses. So these public IP addresses are vulnerable to DDoS attacks. Attackers can start different types of DDoS attacks that can overwhelm your workloads, your infrastructure that you have. It can bring down your applications, and Azure DDoS protection is there to provide always-on protection against layer 3 and layer 4 DDoS attacks. It's very easy to configure, and I'll also show you in a bit in the demo, and also provide you with some best practices about DDoS protection. So starting, I'm sorry, just gonna go back. So just to mention that this is the network SKU. We have two SKUs. It's the first thing to mention. And you can see here, this is the other SKU, which is the IP SKU. More or less, when it comes to the capabilities of the protection it provides, they are identical. The main difference is gonna be about the pricing and also about the extra features you get, like, for example, cost protection, rapid response support. So it's more targeted towards, let's say, smaller customers. So if you have only 5 public IP addresses and you don't want to enable the network protection, you go with IP protection, which makes a lot more sense when it comes to the cost. And here's main comparison between these two. And as I mentioned, when it comes to the capabilities, the protection features, they're more or less the same. You have full global network protection. You have inbound, outbound DDoS protection, mitigation reports, alerts, and all of that. The main difference is rapid response support, cost protection, and WAP discount, which I will speak a bit more later, so you understand really the main difference between them. So I'm going to start with the DDoS protection scale, just to understand the scale of the protection that you're getting. So currently, at least today, we have the mitigation scrubbing machines in 62 different regions, and we are increasing also that. Same thing also with the mitigation capacity. It's now more than 90 terabits per second, and that's also increasing with time and with more data centers that we are adding. We do have around more than 2,000 attacks that are mitigated daily. You probably heard about the latest attack that happened in Australia with more than 500,000 different source IPs that was mitigated and that targeted just one specific public IP. And something important also to mention is that it provides protection for inbound and also outbound DDoS attacks, right? Which is very important to mention. And as you can see, there's a huge capacity, and there's usually 2 different types of mitigation. If it's a smaller attack, the mitigation happens directly at the destination data center, where is the public IP address. If it's coming from, or if the threshold is very high, it can also impact that data center. Then the mitigations happen at the source where the packet enters the Azure network, which that's the reason why it provides such a huge mitigation capacity. And this is the same for any public IP address that you enable Azure DDoS protection on. One other important thing about Azure DDoS protection is the adaptive tuning. So the adaptive tuning will use algorithms, and it will look at the traffic patterns. It will understand the volume, the patterns of the traffic that is going through your public IP address. It will also look at the attached resource, and let's say you have your public IP address attached to Azure Firewall. If the Azure Firewall scales in or out, it will also take that into calculation, and then it will create a profile for your public IP address. So it will set 3 different thresholds. The first one is TCP, second one is TCP sync, and then UDP. So it will have different thresholds. If these thresholds are exceeded, then it will start sending the traffic to our mitigation pipelines, and then it's checked if it's malicious or legitimate. If it's illegitimate, then it's forwarded, of course. And this is a very important thing I want to mention here, because you will have different workloads, different type of traffic, and each public IP address where you enable DDoS protection will have the specific profile for it based on the algorithm, what it learns from the traffic and the scaling out. And so that will be different. It doesn't matter if you have the same DDoS plan. It doesn't matter if you're using IP or network protection. It will have different thresholds for all of them. When it comes also then, when there's DDoS attacks, it's also important then to investigate, to have alerting in place, also respond in case there's different type of attacks. And that's why the Azure DDoS protection is rich when it comes to the analytics and also metrics. I will also provide a bit more details into that, into logging and metrics, and also what's the best way actually to look at these logs, right? Or metrics, how best to do it, and what's easier to create these reports. Then there's also, we have the DDoS integration with Network Security Hub. So Evren also mentioned earlier, for example, you have your Azure firewalls, you have your WAF. So you can use the Network Security Hub, which actually before it was renamed recently, and before was called Azure Firewall Manager. And as you can see from the screenshot, it's still the same. But what you can do from here is that you can manage all your network security from this point. So you don't have really to go to your plan or anything like this. And you can directly here look at your VNets. You can see, for example, which one has a firewall policy, which one has a DDoS protection enabled, and you can enable it directly from here, which is a lot easier to manage. So central, like plain glass, where you can manage all your network security. And this is another important thing, and this is the workbook that we have, and also the Sentinel integrations. I will show you also this. I recommend this to every customer I usually speak to. It's very easy to deploy. We have it in our documentation. We have it also in our GitHub repository. You can just deploy it one click and start using this workbook, and it aggregates all the logs and metrics from all your public IP addresses into one report. So it's easier to then create, use this report to provide information on the attacks, investigate, and understand really what's happening. Then we have also some integration with Microsoft Defender for Cloud, of course. If you're using MDC, then you can also get recommendations. For example, if you have unprotected public IPs that should have DDoS protection enabled, you'll have also alerts integration, like in the same single dashboard, and also some regulation compliance recommendations based on this. And one also really good solution that I wanted to mention is the solution we have for Microsoft Sentinel. And this is a solution where there is a scenario where the attackers, sometimes they will start with a DDoS attack, and just to test this, test the load, see like how which public IP address, for example, are open, which one they can take down. And after that attack, first attack, what they will do, they will sometimes use the same source IP, same machines that they started these attacks with, and start different types of attacks, right? Yeah. So what you can do with this solution is that after the first initial attack they start, it will automatically take all of those source IPs it found in that DDoS attack, and it will add them to your firewall, and not just specifically Azure Firewall. So if you're using Azure Firewall, that's okay, it can add it there. If you're using Checkpoint, if you're using Palo Alto, it will also add it there. So this solution works for all of them. And additionally, we have also one for Azure WAF. So it works also for Azure WAF. It will add, it will create a custom rule there, and then it will add these source IPs, so it will block them from initiating another attack. So it's all automated. Once you deploy the solution, you don't really need to configure anything, and it starts automatically. Once the attack starts, it will add those IPs, which is very useful for some types of attacks.
Salim, should we also
Yeah.
add for the WAF component that when a customer is leveraging Azure DDoS network level protection, and if you decide to use WAF on top of App Gateway, then customer is not going to pay for the cost of the WAF. Is this a correct statement?
Yes,
All right.
that's correct. Yeah, absolutely. You're correct here, Evren. So basically, if you're using the network SKU, right? So you have the DDoS plan where any VNet where you have the DDoS plan enabled, all the WAF part or cost for the application gateway is discounted at 100%, right? So you're
And
basically
also, yeah, it's free, right? Basically, they're
you're
getting
basically paying for the
WAF
standard.
component.
Yeah.
Yeah,
Yeah,
exactly.
exactly. Yeah,
And plus,
exactly.
with the Azure DDoS network level protection, before there was a cost associated with the egress, so there's no more cost, and the customer is actually not charged for the egress control or egress costs. Am I correct on that?
Yes, they're at least for the WAF part. Yes, that's correct. They're like when customers thinking about this, it's basically like if they have it enabled on the VNet, they have application gateway WAF SKU, they can simply look at the calculator of a standard application gateway, and that's the cost that they will basically pay. So all the WAF part of it is discounted at 100%. You're correct there.
Yeah, this is actually something that Salim and I have been working on a very big project, and then this is one of our actually convincing points to our customer. Basically, they were worried about the cost of the WAF. So, and then we mentioned it. They already use network level protection from DDoS. So, and then we gave them the surprise and said, you're not going to pay for the WAF component, and you're going to continue to pay for the standard SKU, and they actually jumped in the air. So everybody to know, if you have your plans to move to Azure, get the DDoS network level protection, because you're gonna have it to protect your assets, and on top of that, you will have the WAF web application firewall, which is enabled on the app gateway, and that WAF component is gonna be free as long as you have the Azure DDoS network level protection, free.
And
Perfect.
2 weeks ago, we had the public preview for the DDoS rule set layer 7 on WAF. So you get also that extra protection, right?
That is awesome.
In addition to this, right? So I think there's a lot of
Super
good things there. Thank you for reminding me, Ren. So the next thing I wanted to mention is the rapid response support that you get, and this is again specifically to the network plan. So this is a dedicated team that you get support when you have the Azure DDoS protection network plan. You can engage with them. They can investigate, for example, previous attacks, look at different metrics and logs. Let's say, for example, if you were under an attack and the mitigation didn't work as you wanted, or there's a case maybe if there was an attack and mitigation didn't really kick in, then that's where you can engage rapid response team. They have specific SLA, so they're very fast in responding to you, and it's really good that customer has someone that they can work with, investigate, look at these things, and also really get help, and also do configurations if they don't like the threshold, so they want to make some changes, which I think is really useful to have. The next thing also that we have is the DDoS SLA guarantee and cost protection. So there's a 99.99% SLA guarantee. We do also have the same for guarantee during the attack. The target resource will not be impacted. And then also an important part, which is the 100% service credit for resource cost incurred as a result of a DDoS attack, right? And basically what this means, just going to give you a quick example. Let's say like you have an application gateway, you have DDoS protection enabled on it. It scales out, so you're paying more for that scaling out, right? And also for the traffic. If that was because of a DDoS attack, then you get all of that extra cost back as service credit. Yes, so you have that cost protection with that SKU. Yeah.
Cool.
All right. So yeah, so just the last parts I have here is I'm just going to talk just a bit about the cost. So the network protection costs around 3,000 months for the entire tenant. This is very important to mention because I've seen customers using more plans, and I think you can use like one plan to protect all the VNets and subscriptions you have. You'll have the same level of protection, and then there is $30 a month for each IP above that 100. And as you can see here, it's mentioned the cost protection. You have access to rapid response support, and then also the WAF 100% discount mentioned here. You have that. So this is the network SKU. Now for customers who, let's say they have less than 7 public IP addresses, 5 public IP addresses, and they don't really want to you don't really need the rapid response support or the other features, then you have the IP protection. Basically, you enable it on specific IP, and it's $200 per month for this type of SKU. So one last thing before the demo, I just wanted to mention, which I think is very important, because customers also asked me about the basic DDoS protection, which is available now. It's called infrastructure level protection. And what's the difference between this and the DDoS protection, the network and IP SKU, right? So the infrastructure DDoS protection is there to protect the Azure platform itself, right? And what I mean by this, if there's a huge attack that is trying, for example, to bring down Azure services, so services that your applications are running on, or for example, like Xbox or other services, then there's the infrastructure protection to protect against those massive type of DDoS attacks. Now, the application specific that are targeted towards like your applications, and I'm just going to give you an example, right? Let's say there's an attack of 400,000 packets per second. Let's say it's TCP sync flood attack. For Azure, that's just traffic. That's just normal traffic. More customers have like 10 times, 100 times more. But for you, let's say for your application, that can bring it down. Whatever, if it's the infrastructure or the application, right? At the where you're running the application itself, and that's where the Azure DDoS protection comes in with its adaptive tuning that understands your application. It can set the right thresholds for it. Once these thresholds are exceeded, then it will start the mitigation, and it will mitigate that attack, that TCP flood attack, for example, right? And that's the main difference when you're thinking about the infra and also the Azure DDoS protection. So if you do have a public IP address, more likely or not than not, you will need the Azure DDoS protection to protect your resources that need specific thresholds for them, right? So that's the presentation I wanted to give. I wanted to speak a bit more, but show you also some things on the demo, if that's okay.
Yes, it would be great. Yeah, absolutely.
Awesome. So let me stop sharing this screen, and I'm gonna just start sharing my other screen, which is over here. Let me know when you can see it.
Yes.
And I'm gonna just zoom in, just so that it's easier to see. All right. So there are 3 things or 3 sections I wanted to look at, which I think is important. The first one is how to actually enable DDoS protection, right? It's extremely easy and straightforward, and I'll show you now how it's done. So I have here the DDoS protection plans resource. I'm just going to click on it. It will open. You can see that I already have 2 plans here. To create a new one, you click on create, and you'll have to choose the resource group, name, and region, and that's it. The region doesn't really matter because you can protect any resources you have under that same tenant. So you can choose the preferred region you have. You click on create. In a few seconds, you'll have DDoS plan. So that's the DDoS network plan created. Now, once it's created, and I'm just going to open the one we have here. So you're going to go on your DDoS protection plan, and then click on the settings on protected resources. That's the important one we care about. And basically here, what you do, you will click on add, and select the resource group you have, subscription, and then specific VNet. Once you select the VNet, you click on add, and it's added here. You will see that we have 3 VNets, which means that all the public IP addresses and those VNets have Azure DDoS protection enabled, adaptive tuning is enabled, and that's mostly it. So this is Azure DDoS protection enabled and running, and the resources protected from layer 3 and layer 4 DDoS attacks, right? Now, and you can see also here all the different type of resources. For example, you can see we have this public IP address attached to a firewall. You can see this one, for example, is an application gateway. So this first part, I wanted to show you more or less how you can enable it. And it's, as you can see, it's pretty straightforward, but there's another important step that you will need to do if you want to have more information, right? And I'm going to give you a scenario, right? So Evren also mentioned earlier, let's say you have application gateway and you have behind this application gateway, for example, an app running that you have a website there, right? Now, and this application gateway, as you can see, like, let's say it's this one, and this is the public IP address that is attached to it, and it has DDoS protection enabled, right? So I'm going to click on it and open it. Now, on this public IP address, now if I want to look at if it was under DDoS attack or not, right? I'm going to go over here, metrics, I'm going to open metric here, and I'm going to click here under DDoS attack or not. And it will show me that there was no DDoS attack, at least in the last 24 hours. That's the metrics that we have. So this is, we don't need to enable this. It's already available. Something important also you can check here. You can check directly the thresholds. So this is the threshold we have, for example, for UDP. That's 60,000 packets per second, at least for this public IP address. This can change depending on what I mentioned on the algorithm, adaptive tuning. And you'll find very good information, but that's mostly what you get if you don't enable anything else, if you don't enable logging specifically. And that's where what's really important. And I know some customers are not doing or they don't do after they enable DDoS protection. So to enable logging, you go to diagnostic settings over here, and you'll have to create a diagnostic settings like this one, for example. So I'm going to open this diagnostic settings, and you'll see here we have we are sending all of these categories to our log analytic workspace.
Yeah.
And these are the three categories that we have for DDoS. Now, when you're thinking about which ones they should be enabled, like should I send all these to my log analytic workspace or some other, for example, location that you're using, it depends really. The first one is DDoS notifications, which is gonna generate exactly 2 logs each DDoS attack. So it will generate 1 log for when DDoS attack starts, and it will tell you which public IP address is affected. And then it will generate another one when it ends, and for which public IP address, right? So it will tell you there's an attack, this type of attack on this public IP address. Now, where this is very useful is that you can create alerts based on this. So for example, let's say you want an email alert, SMS alert when there's a DDoS attack. You have maybe an automation. You have a response, for example, plan where this should create like a ticket in the SOC if there's a DDoS attack. And this log is very useful for that, and you can create a lot of things based on this. The second one is the flow logs. This is going to be the one that generates like most of the logs, because it will generate like a sampled version of all the packets that are going through the mitigation pipelines when there's a DDoS attack, which means that depending on the traffic, it can be millions of logs generated at that like 5 minutes or that interval. It's also very useful, but it can be a bit costly, right? So depending on the customer needs, this can be useful if you want to see exactly like the packet, what source it came from, the port, what happened, like if it was dropped or if it was forwarded. Now, the last one is the reports. This is going to generate like every 5 minutes a report, incremental, then at the end one for the whole DDoS attack. And this will give you also a lot of very like aggregated but important information. So these are the 3 categories I wanted to mention. Again, like what you want to enable really depends on the needs that you have, but I definitely recommend at least the notifications and the reports of DDoS mitigations, because that comes also to the other part that I will speak in a bit, which is the workbook that I want to share. So these are the loggings. Definitely enable them if you want to investigate, if you want to know what's happening during an attack, and also create reports that you can share with your organization. Now, let me show you how actually they look like. So here, this is the log analytic workspace that we have. So we are sending all the logs over here. These are the 3 categories, and I'm going to start with the notifications, right? So I'm going to run this notification query. And what you can see here is we have 4 specific logs. So we know that there was DDoS attack, and I'm doing a custom time range. So we know there was a DDoS attack, for example, like on this specific public IP address, and you can see also when it was generated, which was 19th of September. Now, if I open it, for example, for this first one, it will tell me the message mitigation stopped. So this is the notification telling me mitigation stopped for this IP because the inbound traffic is below the threshold. So to give you that simple information, it's not that much, but it's very useful for alerting. Now, the second one I want to show you is the reports. So I'm gonna run this one. Okay, let me try again. It's not taking this. All right, now it's working. So this is the report. So this will generate again every 5 minutes and then one at the end. Let me open, for example, let's choose this one, right, and see what's showing me here. So you can see this is a report type incremental. So we know that this is not all the details of that DDoS attack, but it will give you information about the IP address, or like total packets, the protocols, which are the top source countries. You can see it's United States, for example, and so on, right? And if you want like, so this is information for this specific attack on this public IP address, right? The last one is the mitigation flow logs. So I'm gonna run this. This generate higher number of logs. And as you can see here, there's quite a few because this is gonna show you all the decisions that were made. And you can see in this example, the message is protocol violation, invalid TCP sync. So the packet went to the mitigation pipeline, the scrubbing machine, it sent back the TCP sync handshake to finish it, and then it didn't reply, which means that this is invalid and it was part of the attack that we saw. And you can see here that this is the source IP address, is where the attack came from, the source port, and the destination in this case, right? So it will give you this exact information. Now, all of this is very useful information, but the problem is that this is for, like, these logs are for every public IP address. When you have like hundreds, for example, public IP addresses, it's very hard to just look at these logs and really get an idea of what's happening in the type of the attack. Now, the best way to aggregate that information and to have really an easy view on what's happening, and like also to be able to create reports based on it, is to use the workbook that I mentioned earlier. So I'm going to go here to Azure Workbook resources, and we have one that is already deployed, but it's very easy to deploy using the template that we have. So we have 3 of them here. I'm going to open this one, which is linked to the CyberSoc. And I'm going to open the workbook just to show you how it looks like. Let me remove this one. And the first thing I'm going to do is select the workspace, which is the CyberSoc that we have. And now you'll see how it looks like. So this is like the workbook. It's really good view for, let's say you enable your Azure DDoS protection, you have a lot of IPs. Now you want to look at what's happening, right? Like what's the information that you get. You can see here like the traffic overview, for example, like the total packets, how many were dropped, like the TCP packets, TCP dropped, and so on. Here you can see, like, for example, the last 10 DDoS attacks. You can see like the amount of traffic. You can, like, for example, this DDoS attack was pretty small, but this one 33 million packets, which was bigger. And if you want, you can also click on it, and it will filter the page by that specific DDoS attack, and you can go deeper and have like investigate further that specific attack. You can see like also the affected resources here on the right, so all in the same place. You can see the countries of origin, from where the attack came from, like which protocols, which continents, AS numbers, and also the drop reasons for that. Also that information here. And here you have like that information I showed you, the logs, the mitigation logs, and so on, right? So again, this is really useful. You can also go here to metrics and look at, for example, all your public IP addresses. You can see all the information about the packet, like the average packet count. You can see all the thresholds that are set, the one I showed you earlier. So it's easier than going to each public IP address.
Nice.
You can manage all of it just at the same place. And the last one I wanted to show you is the DDoS investigations, which will show you, you can go deeper like into the investigation. So you, for example, here you can see like which ports were allowed during mitigation. You can see what are like the top attacking IPs during these mitigations. You can see here those IPs that were attacking you, and you can do that then here a deeper in-depth investigation into like specific affected IPs and what happened with that. So this is the workbook. I think it's very useful if you're using Azure DDoS protection. I hope this was useful and gave you also like an idea of how to create DDoS protection, some best practices, and really how to look at like the alerts and also metrics.
No, this was really great, and thank you so much for this live demo and walking us through there to the workbooks. Maybe you can also share a few links to help customers get started with this that we can put on the show notes. But I think this was really great.
Absolutely.
Perfect. Then Evren, as always, it was great to have you. Saleem, it was great to have you and walk us through this as well. I hope we can see each other again in the podcast.
Exactly.
Maybe with a follow-up and another deep dive. But for
So
now,
if anybody has any questions, they can also reach out to you, and then you can just like, maybe, delegate those questions to us and we can answer any questions. So people definitely, can go ahead and just ask any questions that they would like answers. So we're ready to help.
Perfect.
Absolutely.
Thank you so much, and have a nice day.
Thank you so much, Holger, for hosting us.
Thank you, Holger.
My pleasure.
Thank you, Evren.
Thank you.
Thank you.
Thanks a lot. Goodbye.